Welcome back. Introduction to Euclid Geometry for ninth class.
The word geometry is derived from two Greek words such as geos, meaning earth, and metron, meaning measure. Geometry was extremely important for ancient societies and was used for surveys, astronomy, and navigation, and for building purposes. Geometry, which we are familiar with, is actually known as Euclidean geometry, which was written in ancient Greece by Euclid, Pythagoras, Thales, Plato, and Aristotle. The most fascinating and accurate text of geometry was written by Euclid and was called Elements. Euclid's text has been used for over 2000 years. Euclid's method consists in assuming a small set of axioms and postulates and deducing many other theorems from these. In this chapter, we will study the following concepts: Euclid's definitions and axioms, Euclid's postulates, Euclid's definitions and axioms. Point. When we make a dot with a sharp pencil on a paper, then it represents a point. The position of any object or any person can be represented by a point. For example, a man is walking. Then his footprints can be represented by points. Some more examples of point are given below. The position of a bowler and a batsman. The spot to which a straight path is made. That is, a straight path from one point to another. Act of pointing our feet in certain dance positions. A mark made by a sharp needle-like instrument. Line. Line is a collection of points. A line has infinitely many points. Lines can be of different types. They can be long or short, straight or curved, horizontal, vertical, or diagonal. The ends of a line are points. Through a given point, there passes infinitely many lines. Surface. The exterior part of anything that has length and breadth is called a surface. The edges of a surface are lines. For example, the surface of a book. Some more examples of surface are given below. The surface of a table, the surface of the earth, the surface of the floor, the surface of a glass. Plane. A perfectly flat surface is called a plane. It is a collection of infinite number of lines. Geometrical plane extends endlessly in all the directions but has zero thickness. Plane is without elevation and depressions. Some examples of different types of planes are given below. A tool used for smoothing boards or other surfaces of wood. The jack plane, an ideal surface conceived as coinciding with or containing some designated astronomical lines. The plane of an orbit, the plane of the ecliptic or of the equator. If we have two or more planes, then they can be parallel to each other or they can intersect each other. An axiom is an assumption which applies to all the branches of mathematics. You are familiar with many axioms used in solving an equation. These are also called common notions. Euclid's axioms. Axiom 2. If equals are added to equals, the wholes are equal. That is, if x is equal to y, then x plus z. Axiom 3. If equals are subtracted from equals, the remainders are equals. If x is equal to y, then x minus z is equal to y minus z. If x plus 9 is equal to 10, subtract 9 minus 9 is equal to 0. It implies x plus 9 minus 9 is equal to 10 minus 9. It implies x is equal to 1. Axiom 4. Things which coincide with one another are equal to one another. That is, if two things are identical in every aspect, then they are equal. For example, if two circles with center O, O' are such that one superimposes the other, then the area of two circles are equal. Axiom 6. Things which are double of the same things are equal to one another. Example, consider two equal lines AB and XY, that is, 2AB is equal to 2XY. Axiom 7. Things which are halves of the same thing are equal to one another. That is, if x is equal to b upon 2 and y is equal to b upon 2, then x is equal to y. Euclid's postulates. Postulates are the assumptions that are linked specially to geometry only. Euclid gave 5 postulates which are related to geometry. Postulate 1. A straight line may be drawn from any point to any other point. Euclid's axiom for this postulate is axiom. Given two distinct points, there is a unique line that passes through them. In the diagram, we see that through the two distinct points P and Q, only one straight line, PQ, is passing through both of them. Postulate 2. A terminated line can be produced indefinitely. For example, we can produce line AB indefinitely from both the end points A and B. Postulate 3. A circle can be drawn with any center and any radius. Postulate 4. All right angles are equal to one another. Postulate 5. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles are less than two right angles. Equivalent version of Euclid's fifth postulate. If the sum of the interior angles on the same side of the falling line is exactly 180 degree, then two lines will not intersect. For every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Clearly, of all lines passing through the point P, only line M is parallel to L. This is known as parallel lines axiom. Another equivalent version of fifth postulate is two distinct intersecting lines cannot be both parallel to the same line. Theorem. Two distinct lines cannot have more than one point in common. Proof. Here we are given two lines L and M. We need to prove that lines L and M have only one point in common. For some time, let us consider that the two lines intersect at two distinct points, say P and Q. So we have two lines passing through the two distinct points P and Q. But this assumption clashes with the axiom that only one line can pass through the two distinct points. So, the assumption that two lines can pass through two distinct points is wrong.
Please like, share, subscribe Mathematical World.